Okay, good afternoon. Today I will be discussing the sample of our performance task so that you have a guide for you to be able to continue working on your performance task. So this is on polynomial functions. So as promised, this is the discussion, or this will be your guide for you to be able to complete your performance task. So let me go back again. Let me start over because there are students that were able to attend during our discussion of this one because they are absent. So this is all polynomial on polynomial functions. What to do with this one in your performance task, you are asked to create your own polynomial function of degree 5 or 6, and then you will find the characteristics. Third, you find the end behavior. Fourth, you find the real zeros of the polynomial function using the test point table. The purpose of this one is for you to be able to determine where is the turning point. Is it above? Is it below? And how do we know that one? So later you will be able to understand using the example that I will be providing. So let's start. So let me zoom this out. Or zoom. Let's start with the first one. Okay. So let's start with this first page. So on the first page, what we're going to do here, so let me use another other color, this one. Okay. So here, so since this is an example of work, for example, of Jerome Pagsisihan, he chose to have a degree 5 polynomial. Here, it is written here. And then a random number was chosen. These are the solutions. So remember, these are the solutions. The factors are the following. X minus 1, if you equate that to 0, when you transpose that, that is x is equal to 1. That's why that is this one, 1. And then we have x minus 2. So because when you transpose that, that is positive 2. Okay, then we have x plus 1. When you transpose that, that is now negative 1. X plus 2, when you equate that to 0, and then you transpose, this becomes negative 2. And then you have, next is x minus 3. When you transpose that, that is equal to positive 3. So these are the roots or the solutions or the zeros. So sa umpisa, meron na kayong solution kaagad, binigay nyo na kayo nagbigay nun. So now, we are working backward. Given the solution, how do we find the polynomial? By multiplying the given factors. So these are the factors now. X minus 1, x minus 2, x plus 1, and then x plus 2, then x minus 3. So sir, how do we go through about it? So how do we do that? By just multiplying it using FOIL method or distributive property. So say for example, x minus 1 times x minus 2. Okay, what you're going to do is to multiply. That is x squared. This is just a sample on how to do that. Then x times negative 2 is negative 2x. And then next multiply, that's negative x. And then next multiply, this is positive 2. So now, you are multiplying these two. You have now the result. Simplify this one. X squared minus 3x plus 2. So, of course, it doesn't end there. After you have this 2 multiplied, you're going to multiply it by x plus 1. So, and then after you get the result of multiplying these two expressions, then you multiply it by x plus 2 and so on. Now you have this one. So of course, you're gonna show the complete solution as it is stated there. So now, moving on the second, how do we find the following characteristics? So sir, what is the degree? Remember, the degree is how do we define the degree of polynomial function? So we take the degree, it is defined as the highest. So the term with the highest exponent will be the degree. Okay? So since x raised to the fifth power has the highest exponent, so the degree is 5. That is there. That's the degree 5. So now let's find out the numerical coefficient. So let's have that in other color. Okay. So the numerical coefficients are the following. So here there is 1 beside. So therefore we have 1. And then the number beside this one is -3. Next, the number beside this one again is -3. The number beside this is +9. The number beside that is +2. And then we have here -6. So sir, why is it that -6 is a numerical coefficient? Wala naman siyang variable. Remember that there is a variable here, x raised to 0. But if you simplify x raised to 0, any number raised to 0 that is equivalent to 1. Take note of that. In the law of exponents, any number raised to 0, the answer is 1. So kaya, if you multiply 1 times -6, still -6. So see, there is a variable here beside -6. So that's why -6 is considered as numerical coefficient. Okay, the leading term. When we say the leading term, the term with the highest degree is the leading term. So since the term with the highest degree is x raised to the fifth power, that is our leading term, x raised to the fifth. Okay, leading coefficient. What is the coefficient, numerical coefficient of the leading term? Since the number beside the leading term is 1, that is 1. Okay, constant. The constant here is -6, so we have it there.